Okay, so in this video, I'm gonna focus on those two important concepts of high performance and user productivity. They are typical of those two programming languages. And before we go into the details, I would like to provide an intuition of why it's important to understand the difference and why it's important to learn more than one programming languages. And at the current times, I think C++ and Python are definitely a great combination. So generally speaking, C++ is hard to use or harder to use compared to Python. It requires more information, has a little bit of awkward process of compiling and executing, and it's much less forgiving about errors and things like that. But when you execute the code can be significantly faster, especially in computations and so on. Python, on the other hand, it's much more flexible, elegant, and allows to write very, very quickly a solution. But then in terms of CPU time, it's definitely less efficient. And so the question is, can people use those two together to get the best of both worlds? And the answer obviously is yes. Most of the libraries that are available in Python are written in C++. And a major goal of this class is to make everybody sufficiently familiar with both languages so that you can write quickly a Python piece of code and then focus only the components that really require efficiency to make everything faster. So I'll work through an example, very simple, but I think it can illustrate the concept in a fairly direct way. So I'll load the code for computing the dot product between two vectors, something fairly simple, and especially something that most engineers are familiar with, and try and draw a direct comparison between the process of creating such code in C++ and Python. In this case, obviously, both are going to be fairly simple, but already I think you can start seeing some significant differences. So this is a project in C++. As you can see, one has to create this top function called main. It's just a standard in C++. That's where any program starts. This printing statements are already not part of the language, so one has to include this IOStream library. Again, something that you can just do following instruction. And so here there is a first print statement, start. We define a constant integer 100,000, and then I create two vectors, v1 and v2, of the size equal to the constant, and the first one is being filled with a bunch of ones, and the second one with a bunch of twos. So very simple. But again, to do this, we need these two special functions, and then here we have a typical for loop. Where we take a dot product set to 0, and then we have a for loop that for I that goes from 0 to n, the dot product is incremented by the product of the two components of index I of the two vectors, and then we print and the value of the dot product. So the way this works in C++, that you have to write this code, you have to build a solution. This creates the executable inside Visual Studio. This is kind of intuitive, but it can become awkward outside. And then we run the code, and as you can see, the start statement that is at the beginning print a start. Then there is a bunch of computation that takes some time. and then there is the end statement here with the print, and then the result of the dot product is 200,000. So in a way, it's somewhat simple, but you can see that we have to declare the type of each variable, a floating point, doubles, integer. So there is additional information. There is this kind of non-intuitive way of writing the print statements. And even for making a loop, we have to create a temporary variable and so on. Now let's look at the equivalent code in Python. So we'll do dot product Python. Notice that one can use Python also inside Visual Studio. So this makes during the semester easy to switch languages within the same environment. So this is the same code. It's a little bit more compact. Most importantly, it does not require a lot of specifications. First of all, you can do print start, just print statement. We declare a variable and we don't have to say if it's an integer or not. We create a vector, and directly with one expression we create a sequence of ones and sequence of two. Initialize the dot product, and then we have the equivalent for loop. Here we don't need the parentheses and so on. Notice actually the indentation of the code actually define that this instruction is inside the for loop, and then we print n and the value of the dot product. So as you can see, similar result. We print start, here it is. We print end, here it is, and we print the result, also 200,000 as a result. So this is a little bit simpler, but also we don't need to compile anything. In fact, if we are in doubt, we can even open an interactive window. This is the Python environment, and we can use Python basically as a calculator. 1 + 1 = 2. But also, if I'm not sure about how a piece of code works, I could copy here, and so I say n, and it give me the number. I want to make sure that the value of v is what I expect, and so now I type v1. Oops, it was capital V1, and here I see this long list of ones, so I can see do a set of things that in C++ I cannot do on the fly. And so this combination of interpreting and running the code makes the development process way more productive or fast in terms of human hours, but now in terms of execution. So just to give a sense though, for something small like this, it didn't seem very visible, the difference. So I'm going to look at a version of the code that would include the timing functionalities. So this is now back to the C code. I imported now this chrono library that does timing. And so here we record the start time. This is the code that we saw before, right in the middle. Then we do the stop time, and then we print the result. Again, there is no interactive window, so every time we make a mistake, we have to figure that out during the building process. Now we build the solution, and we execute the code. And now we have the print statement, and at the end we have the timing statement that says the execution takes 1200 microseconds, so 1200 microseconds. So just to give a sense what I was trying to do before in the command line, if I try to do something in C++, all I get is error codes in the, so for example, if I create a different variable, now it says, oh, here v with n is a problem, the variable does not exist. And I have to think, oh, by mistake here I did type n, and now I can build again, and the error goes away. So it's a little awkward and indirect process, and now everything compiles to do things because I don't have the interpreted environment. So let me go back now to the Python version of the code with timing. So this is the code we have seen before in the middle. Now we imported a timing library called datetime. We read the time A at the beginning, and then we read the time again at the end, do the difference, and print the timing. And so now you can see 64,000 microseconds instead of 12,000. So here it's basically 60 times slower. So think about a piece of code that would run half a day that you could run overnight, and that's typical for many engineering code. If it gets 60 times slower, it would take a month to run. And so something that you could run in the evening, pick up in the morning, and just keep working with, which is typical for engineering, would become virtually impossible if it was purely computed in Python. And that's why the two languages work really well together. If in Python, and we'll see how that works, we can replace this piece of code with a call to a C++ code, we get the best of both worlds, something easy and flexible to write, and something that can be executed really fast. I hope this clarify this idea of high performance versus high productivity. It's something very important when you embark the choice of languages. And so in this, the first part of the semester will focus on the C++ with all the difficulties of dealing with different type of numbers and having to deal with the memory allocation and so on, but with code that can be really fast. And later on, we'll look at Python and look at building the outer shell of an application with user interface and so on. And I hope this is well clarified the concept. Thank you.